Determine the distance from the point having the coordinates 2, 5 to the line whose equation is given as 3x plus y plus 4 equals to 0, measured parallel to a line having a slope of 3 over 4. Okay, let's try to understand the problem graphically first. So here we have the point, let's call it the point A with coordinates 2, 5, and we have another straight line 3x plus y plus 4 equals to 0. Okay, so here our goal will be to determine the distance of the point A from this line with the condition that if we join the point A with the straight line, let's say we join it and it meets the straight line at some point B, then we get the line segment AB. This line segment AB is going to be parallel to another line whose slope is given to us. That means we have another straight line, let's call it L prime, and this particular line has got a slope of 3 over 4, and this is parallel to AB. So in other words, we can say that the slope of AB that is also going to be 3 over 4. So using all of this information, we need to find out the equation of the line. However, before proceeding, let me clarify here that the equation of the line is given as 3x plus y plus 4 equals to 0. Now when we convert it into the slope intercept form of a line, we will see that this particular line is going to have a x-intercept and y-intercept in the negative x and negative y direction. But in our diagram here, we have considered the positive x and the positive y-intercept. This is for simplicity. Now this is done so that we can easily understand the problem, what is going to happen. But this is not actually the actual figure for the line. It's the actual diagram of the line. So let us begin. So here, how shall we proceed? So what we'll do here, we'll be using the distance form of a line. Let's quickly recap the distance form of a line. Let's say we have a point with the coordinates x, y. We have another point having the coordinates x1, y1. Let's say we have a straight line that passes through these 2 points, and the distance between these 2 points is denoted by r. And also this line, let's say it makes an angle of alpha with the positive direction of x-axis. Then the distance form of a line states that we have x minus x1 divided by cosine of angle alpha. This is going to be equals to y minus y1 divided by sine of the angle alpha, which is going to be equals to r, and r is going to be the distance between the 2 points that we have considered here. So this is referred to as the distance form of a line. So we're going to take the help of this distance form. So what that means, in order to find out the distance form, we need 2 points. So here we already have the point A with coordinates 2, 5. So we have another point B. So B is the point which the line AB, line through AB, the points A and B is going to intersect the line 3x plus y plus 4 equals to 0. So let's name this as the point having coordinates x, y. So what we will do, we're going to apply the distance form to the line segment AB. So our distance form is going to give us x minus x1. So here x1 is going to be the x coordinate of point A, so that's 2. We have x minus 2 divided by cosine of angle alpha. This is going to be equals to y minus, so we need the y coordinate of point A, so that's 5. We have y minus 5 divided by sine of angle alpha. And let's say this is equals to r, where we are supposing that r equals to AB. So that's what we need to obtain here. We need to find out the value of r. Now, we need to find out the value of cosine alpha and sine alpha also. It's given here. It's given in the problem that the slope of L prime. So this is given as 3 over 4. Now, if this is the slope of L prime, then we can say this is also going to be the slope of AB, since we know that the slope of parallel lines, they are equals to each other. So we can say slope of the line L prime is going to be equals to slope of the line segment AB. Okay, now what is slope? Slope is simply defined as you take the tangent of the angle that the line makes with the positive x-axis. So let's say it's making an angle of alpha with the positive x-axis. So this is going to be equals to 3 over 4. So now we have tangent of alpha equals to 3 over 4. We need to find out cosine of alpha and sine of alpha. Okay, so let's try to find out the value of cosine alpha and sine alpha. Okay, so for this, let us consider a right angle triangle. So here we will consider a right angle triangle. So let's say this is the triangle ABC, which is right angled at angle B. Angle C, that is the acute angle alpha. Now, what is tangent of alpha? Now, we know that the tangent of angle alpha, this is defined as the ratio of opposite to that of the adjacent. So here opposite, that is AB, and here since we have AB is 3, so we can consider AB to be 3, and BC, which is the adjacent, that is going to be 4. So now when we use the Pythagoras theorem, then AC is going to become 5. So we have obtained all the 3 lengths of the sides of the triangle. So that means we can easily define sine of alpha and cosine of alpha. So this is going to give us sine of alpha as the ratio of the opposite to that of the hypotenuse. We will get 3 over 5, and cosine of alpha, that is going to be the adjacent, which is BC, to that of the hypotenuse to give us 4 over 5. Okay, so let us substitute this back into our distance form. So we are going to get x minus 2 divided by, so we need cosine of alpha, that is going to be 4 over 5. This is going to be equals to y minus 5 divided by sine of alpha. So sine of alpha, that's 3 divided by 5 equals to r. Now what we'll do, we can rewrite this as x minus 2 divided by 4 over 5, that is equals to r. Or we can write y minus 5 divided by 3 over 5, that is equals to r as well. Okay, now what we can do here, so x is going to be equals to 2 added to 4r over 5, and y is going to be equals to 5 plus 3r over 5. Okay, so successfully what we have done, we have converted the coordinates of point B. So coordinates of the point B, which we initially considered to be x comma y. So now we have converted it into its parametric form as 2 plus 4r over 5. So that is the x coordinate, and the y coordinate in its parametric form is 5 plus 3r over 5. Okay, now we need to find out the value of r. So here we are going to use the fact that this particular point B also lies on the straight line 3x plus y plus 4 equals to 0. So it must satisfy the equation of the line. So here we can say that since B lie on the line 3x plus y plus 4 equals to 0. So we are going to get, we have 3 times x. Now in place of x, we're going to replace it with the parametric form of x. So that is 2 plus 4r over 5. Added to y, so that's 5 plus 3r over 5. Added to 4, that will be equals to 0. Okay, so let's distribute 3. So we get 3 times 2, that's 6. Added to 3 times 4r, so that's going to be 12r over 5. Added to 5 plus 3r over 5 plus 4 equals to 0. Okay, let's further simplify. We have 12r over 5 added to 3r over 5, so that's 15r over 5 equals to, so 6 plus 4, that's 10, 10 plus 5, that's 15. So we'll transpose it to the right hand side to get negative 15. So this is going to give us r equals to negative 5, but r, that is a distance. So what we'll do, we're going to consider only the magnitude. So magnitude of negative 5, that is going to give us positive 5. In other words, what we have done, we have successfully obtained the value of the length, or you can say the line segment AB, which comes out to be equals to 5 units.